Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video you will learn about chapter 3 numerical method in new subtopic 3.4 numerical integration. Numerical integration is a numerical method that will integrate a function at some point to determine the area under the curve over interval AB. Let's say we have this graph, fx graph. So when you integrate from A to B, integrate fx A to B, then you get this area under the curve. So in today's lesson, we will learn how to approximate area under the curve of a function fx over the interval AB. There are three methods that will be considered in this numerical integration. First is midpoint rule, trapezoidal rule, and Simpson's rule. Let's look midpoint rule. Midpoint rule is a numerical technique to approximate the area of rectangle which form under the curve fx. We determine area under the graph using this rectangle. Let's see definition for midpoint rule. Suppose the function fx is continuous in AB. This fx continuous from A to B. Where n number of rectangle with equal step size h are formed under the fx, and the fx star is intersect at the midpoint of the rectangle. For this fx, for example, we have n number of rectangle. For this graph, we have 1, 2, 3, 4, 5, 6 rectangle. For each rectangle, the step size is h. So the integration is approximately fx from A to B is approximately given by h times fx1 star plus fx2 star plus until fxn star. Where the x star value is the midpoint. X star is the midpoint. That's why this method is called midpoint rule. Let's say the starting point is x0. A is x0. So, and the second point is x1. So, to find x1 star, x0 plus x1 divided by 2. To find x2, x1 plus x2 divided by 2. And so on. Then you determine the value of fx. You substitute x1 star, x2 star, and so on in fx. Let's see example 1. Use midpoint rule with 4 subintervals to compute this integration. Use 4 decimal places in all calculation. This is the formula for midpoint rule. First of all, you have to know what is fx and what is A and B. For this equation, our fx is equal to square root of x. For A equal to 0 and B is equal to 2. So next you have to determine h. H is equal to b minus a divided by n. So for this question, b is equal to 2 minus a is equal to 0 divided by n. Okay, n is the number of subinterval. So for this question, the subinterval is equal to 4. So 2 minus 0 equal to 2 divided by 4, you get 0.5. Okay, it is more easier to use a table for next step. So I is the number of iteration. Okay, next is xi. Next is xi star and fxi star. Okay, for I, okay, we start with 0. Okay, 1, 2, 3, 4. Okay, our n is equal to 4. So n is until 4. Okay, so for xi, okay, xi start with 0. Okay, not xi star and xi star. So for x1, okay, x1 is h plus 0. Okay, our h is 0.5. Okay, 0.5 plus x naught. Okay, so next is 1. Okay, 0.5 plus 0.5, you get 1. Next 1 plus 0.5, you get 1.5. And 1.5 plus 0.5, you get 2. Okay, last must be equal to 2 because our b is equal to 2. Okay, next for x I star, okay, is the midpoint. So 0.5 plus 0, okay, our xi x1 star is equal to 0 plus 0.5 x naught plus x1 divided by 2, you get 0.25. x1 star is 0.25. Okay, next for x2 star is 0.5 x1 plus x2 plus 1 divided by 2, you get 0.75. Okay, 0.75. Okay, next is 1.25 and 1.75. Okay, next is fxi star. Okay, you just substitute this value xi star in this fx. So you get 0.5, 0.8660, 1.1180, and 1.3229. Okay, next you just substitute the value in the formula. So fx is square root of x from 0 to 2 dx approximately h times by fx star 1 plus fx2 star plus fx3 star plus fx4 star. You must remember our n is equal to 4, so fxn is until f4 star. Okay, so our h is 0.5 times, okay, fx1 star is 0.5 plus 0.8660 plus 1.1180 plus 1.3229. Okay, you just add up this value, then you get 0.5 times 3.8069. Okay, so the final answer you will get 1.9035. Okay, trapezoidal rule is a numerical technique to approximate the value of numerical integration by using n number of trapezoidal, which form under the curve fx over the interval AB. So let's say our fx is equal to this graph. Okay, so the trapezoidal, okay, the number is trapezoidal is here. This is the trapezoidal. Okay, here we have 1, 2, 3, 4, 5, 6 trapezoidal. Okay, that's why we call this trapezoidal rule. Okay, so the n subinterval, okay, with the equal step size. Okay, our step size is here h h. Okay, for trapezoidal rule, okay, we are given for this formula. So the integration, this integration approximate h times 1 over 2 fa, okay, where a is the starting point, s naught. A is here, okay, plus fx1 plus fx2 until plus 1 over 2 fb, okay, where b is the Sn, okay, until Sn. Okay, so you must remember the trapezoidal rule is given by this formula. Let's see example 2. Use trapezoidal rule with 4 subintervals to compute this numerical integration. Okay, this example is same with example 1, but now we have to use trapezoidal rule. Okay, so this is the formula for trapezoidal rule. Okay, first of all, okay, same with midpoint rule. Okay, you have to know what is fx and what is a and b. So for first step, our fx is equal to square root of x, a equal to 0, and b is equal to 2. So for second step, you have to calculate the h. So h equal to b minus a divided by n. So 2 minus 0 divided by number of subinterval here is equal to 4. So you get 0.5. Okay, next use table to calculate FA until FB. So for the first column is I, next is XI and FXI. So I is 0, 1, 2, 3, 4 until 4 because our n is equal to 4. So for x naught is 0. Okay, x1 is 0 plus h. So h is 0.5. So we get for x1 is 0.5. For x2 1, x3 1.5, and x4 is 2. So for fxi, you just substitute xi in fx. So you get f0, you get 0. Okay, fx1 you get 0.7071. Fx2 you get 1, fx3 1.2247, and fx4 you get 1.4142. Okay, next you just substitute all the value in trapezoidal formula. So the trapezoidal formula is fx is square root x 0 to dx approximate h 1 over 2 fa plus fx1 plus fx2 plus fx3 plus 1 over 2 fb. Okay, so this is fa and this is fb. Okay, so you just substitute the value. So h is 0.5. Okay, 1 over 2 times 0 plus fx1 is 0.7071 plus 1 plus 1.2247 plus 1 over 2 fb 1.4142. So you just calculate using your calculator, you will get 1.8195. So this is the step using trapezoidal rule. This is the last method for numerical integration, which is Simpson's rule. Okay, for Simpson's rule, okay, this method is based on the area under the parabolic shape of the fx over the interval AB. So the area of the parabolic shape, okay, will be used to approximate the curve of the function. Okay, this method is proven to be more accurate than the midpoint and trapezoidal rule since it covers all the area under the curve. It covers all the area under the curve. Okay, next let's see formula for Simpson rule. Okay, numerical integration is approximate h over 3 times fa plus 4 multiplied by summation of fx odd plus 2 times summation of fx even plus fb. So f odd here, okay, let's see the example. Okay, for x odd is x1, x3, xy. Okay, for x even is x2, x4, x6. Okay, I will show the example for Simpson rule in the next slide. Okay, for example 3, okay, we use same question for example 1 and example 2, but now we have to use Simpson rule. Okay. So this is the formula for Simpson rule. So same step. First you need to determine fx equal to square root of x, a equal to 0, b equal to 2. Next step, okay, you have to find h. Okay, b minus a divided by n. 2 minus 0 divided by 4, you get 0.5. Okay, step number 3, okay, you can draw the table for I, xi and fxi. For I, okay, start with 0, 1, 2, 3, 4. Okay, our n is equal to 4. So I until 4. Okay, for xi, x0 is 0. Okay, for x1 is 0.5 plus 0, you get 0.5. x2 you get 1. 0.5 plus 0.5. x3 0.5 plus 1 you get 1.5, and x4 you get 2. Okay, for fxi, okay, you just substitute xi in the fx. So you get 0, 0.7071, 1, 1.2247, 1.4142. Okay, next. Okay. When you want to use Simpson's rule formula, okay, you have to determine the FA, Fx odd, Fx even, and Fb. So for x naught is the Fa, and x4 is the Fb. Okay, for x1 is Fx odd. For x2 is Fx even, and x3 is Fx odd. Okay, now you can substitute in the formula of Simpson's rule. Okay, so 0 to 2 x dx is approximate. Okay, h over 3 times Fa plus 4, okay, summation of Fx odd. So Fx odd here is Fx1 plus Fx3. Okay, plus 2 times summation of x even. So x even here is Fx2 plus Fb. Okay. So you can substitute the value. So h here is 0.5 divided by 3 times Fa is 0. Okay, plus 4 times Fx1 is 0.7071 plus Fx3 is 1.2247. Okay, plus 2 times Fx2 times 1 plus Fb is 1.4142. Now you can use your calculator. You will get approximate 1.8569. So this is the step to when you use Simpson's rule. Okay, I think that's all for this video. Thank you.